Hi, today's lesson we're going to be talking about the natural logarithmic function. This is the inverse of the natural exponential function, or the e function. So what does it mean by its being the inverse? That means it can be reflected over the line, graphically, y equals x. And so our exponential function had a horizontal asymptote and a y-intercept that we discussed. On the logarithmic function, the ln function, this is an abbreviation for the log base e, it will be written as ln instead of writing log base e of x. They abbreviate it to ln. We are going to be having a vertical asymptote of x equals 0. And an x-intercept that we are going to be discussing each time. So, we are going to look at what is the asymptote. And so the asymptote, the x-intercept, the domain, and the range. What are these when we are dealing with a base logarithmic function? The parent function ln of x. So the asymptote, and this is focused in on the red line, we have an x equals 0 asymptote, just like we had on your logarithmic functions. Our x-intercept is at 1, 0. And our domain, again, this is the one we were talking about with the logarithms. We have a change in the one that's going to be restricted. We're going to have domain that's not going to be all reals. And so our domain is going to start at our asymptote, and go to positive infinity. Your range is going to be all reals. So those are where the parent functions are going to start on each of these lessons. So we're going to start here, and then we'll move with our transformations. So remember, the a is not going to change any of those numbers, and neither will if we added in something at the end. Only if we add it into the parenthesis will those numbers greatly change. So when we have an a of 0.5, that is going to be a compression. We're going to see it get closer into the axis there. So we still have that asymptote of x equals 0. We still have the x-intercept of 1, 0. And our domain is going to start at our asymptote and go to positive infinity. Your range is from negative infinity to positive infinity. If we have a number 2, that's going to be a stretch. Again, our asymptote is x equals 0. Our x-intercept is 0, 1. Our domain starts at an asymptote and goes to positive infinity. And our range starts at negative infinity and goes to positive infinity. So our range is going to be consistently, every single time there's nothing that can change our range, we are going to have negative infinity to positive infinity on your range consistently. So we have the parent function ln of x, and our new function is ln of x plus 3. So this is going to make our graph go up 3 units. And just like I didn't make you find the x-intercept exactly, and any question on the assignments that make you do it exactly is going to be taken off. Now, if it asks you to do a decimal, you will still have to find it, because you can find that through Desmos by just clicking on where it's on the x-axis. It will tell you. Only if it asks for an exact value am I going to omit that section from the assignment. We will talk about how to find those later. So our asymptote is x equals 0, because we did not shift it over to the right or left any. Our x-intercept is what we do not have to find unless we have the decimal feature on our calculator, and I forgot to plot that point, so we do not have it, but remember it's something, 0. Our domain is going to start at our asymptote and continue up to positive infinity. And your range is from negative infinity to positive infinity. Now, we are inside the parentheses. So that means we are shifting it either right or left based upon the number. This one is x minus 3. So that means I am going to go right 3 units. And so that means our x-intercept is going to be exact. So 0, not 3. We went right 3 units for 4. So it'll be at 4. Our x-intercept, our asymptote is x equals 3 because we went right 3 units. Your domain starts at your asymptote and ends at infinity. And your range is from negative infinity to positive infinity. So again, think back to the transformations. They apply the same way they did whenever it was log base anything else. So when we are log base E or ln, it is going to have the same transformation. So look at your previous notes and where I broke into the details of each of those. But the only one I'm not going to ask you to find exactly is the x-intercept. And we will discuss how to do that as we go further into logarithms. But for this part of our notes and this part of our lessons, this right here, if it's asking for exact, is going to be omitted.